All right, good morning. I'm just trying to get this set. Not sure if me in the corners can be. I'm not lagging too bad. All right, so I am just providing this as an opportunity for the notes in case you missed it or we're not in class today. Um, Again, if you review these notes, if you understand the Kahoot, you understand my test. I don't try and trick you. I'm trying to show you what you need to know for the assessment on Tuesday. All right, so scientific inquiry is a series of skills used to answer a question. We don't really go through a certain number of steps for the scientific method because everyone has a different opinion about it. But we call the general process, this is a test question, the general process of scientific inquiry is just a series of skills used to answer any questions that we may have. Okay? And again, there are many versions of the scientific method. Some include 5 steps, 8 steps, but a lot of them have these same steps. Some of them include extras. But just in case, I want to go through the general idea behind them. We ask questions which include making observations with the 5 senses and coming up with inferences, which are logical conclusions based on the observations. So if you're looking at my screen right now and you can see that I see the whiteboard behind me, I see the ceiling of my room, I see my short throw, those are all observations. Now, based on an observation, you come with an inference. Now, if you've seen my classroom before, you'd say, okay, I look based on my observations, Mr. Rainey's in his room. In that case, your inference would be correct. But I could be in another room just as easily. You'd have almost the same observations, and the inference would be incorrect. So we rely on observations, not inferences, because observations we can prove. Inferences, again, chocolate chip cookies is the one I keep going to. Like you smell those chocolate chip cookies, you think your mom made cookies, and you go up, there's this new candle. That's an inference based on an observation. Okay? A hypothesis is an explanation of observation, so that's what we're going to test. Always starts with, if I do this, then I can do this because, or then this will happen. That's different than a prediction. A prediction is basically a statement of what's going to happen next in a sequence of events. I'm going to move my little guy here so I'm not so much in the way. Whoa, I got dizzy. All right. When we have a hypothesis, we're going to test it, analyze results. You can test predictions, you can design an experiment, make observations, collect data, and then see if it supports your hypothesis or not. When we're done, we are going to draw conclusions. So a conclusion is basically just what did you learn from the experiment. If we're talking about the dancing raisin lab, what was our conclusion? Well, if we add baking soda and vinegar to the soda, let's get more carbonation, so it's going to dance more. Mr. Krabs understands that the super secret breath mint had allowed more people to have better breath. That's his conclusion. So a conclusion is just a summary. And I always equate it to writing. If you're writing in a story, the introduction tells you what you're going to say. The body says it. And the conclusion reminds me, what did you say? It tells me what you said. So our hypothesis serves that purpose. Our conclusion, I apologize. And then finally, we have to communicate results. That's important because other people have to build off our research. We wouldn't know what we knew unless other people had provided this information for us already. So it could be like a journal, it could be speaking at a conference, a paper, but any other article that would work would be what we're looking for. That's just a way to communicate results. Just trying to figure out what that beep was. If your hypothesis, now here's the question. If your hypothesis is wrong, does that mean the entire experiment was a waste? No. Your hypothesis can be wrong. If I'm at the top of the stairs and I think, well, I can jump down those stairs. If I jump down those stairs, then I will survive because I got mad skills. Now, that's my hypothesis. If I jump down and break both my legs, then I need to revise my hypothesis. And sadly enough, I have to test it again. Well, maybe I can't jump down all the stairs. Maybe I can just jump down one stair and I can test it again. So again, a wrong hypothesis is okay. It helps us learn something. We learn what we did wrong, so the next time we can make that adjustment. So that is also a test question again. A hypothesis is fine to be wrong. You still learn something. Here's another couple of things that are kind of a main point between theory and a law. Remember, theory is an explanation of observations or events that is based on the knowledge gained from many observations and investigations. Theory ends in why, and a theory tells us why. It may not be right, can't prove them, but you can support them with data. So the theory of evolution basically says that we are the way we are because over many generations of adjustments and adaptations by other creatures, we have developed into what we have become. That is the theory of evolution. That's the accepted theory by many people. Some people have the theory of intelligent design, where someone created this, and that's just kind of following logical steps that was designed by somebody else. Some people have the theory that it was spontaneous. We just were dropped here or brought here. None of those theories can be proven wrong. We can support them with data. We can defute them with data, but we can't prove them wrong. And again, they're just explaining why something's happening. Now, a law, on the other hand, tells me something will happen, not why. So I keep using the example. If I drop my pencil, I know that it's going to fall to the ground. Why? Well, because the law of gravity. We know that gravity pulls objects down. Now, when it comes to why that happens, we get in a fuzzy area. We don't know what gravity is. We're still working that out. But we do know that the law is that gravity pulls objects toward other objects. So if I drop my pencil, the law of gravity says it's going to fall. Again, it tells me something will happen, but not why. Okay, some vocabulary that might be showing up on the test. Remember, the observation is a fact that I can prove using my five senses. I'm wearing a red plaid shirt today. Observation, you can prove. Okay? You can see it, you can prove it. An inference is a logical explanation or observation that's drawn from the prior knowledge or experience. If you take a second to answer these questions to yourself, where is he? So look at the picture. Where do you think he is? What season do you think it is? What holiday is it? How does he feel? Why does he feel this way? What will happen next? Now, you can make all those inferences you want, but you can't prove any of those things from that picture. Okay, you say it's spring, or where is he? He's outside the backyard. That could just be a backdrop. What season is it? It's Easter or spring. I don't know. It could be fall. What holiday is it? Well, I say it's Easter because he's wearing the bunny ears. Maybe it's the 4th of July and his parents are just really weird. You don't know. So again, I can't prove any of those. I can't prove any of these questions from the picture because it's all based on inferences. I can make observations. He looks to be outside. He's got rabbit ears on his head, and he seems to have a weird face and expression on his face. But beyond that, I cannot prove a thing. Everything else is just an inference. Remember, a hypothesis is an experiment is if I do this, then this will happen because. It always includes those three terms. It's an explanation, also called an educated guess of why do you think things are going to happen. A prediction is a statement of what will happen next in a sequence of events. It's kind of similar. We use inferences in these, but basically it's kind of what's going to happen next. You see a person on their phone walking, not paying attention, walking in the street. It's pretty easy to make a prediction on what might happen next in that scenario. The independent variable is the one factor or condition that we changed in the experiment. The dependent variable is what happened because of what we changed. So the independent variable might be the use of baking soda and vinegar. It might be the secret breath mint ingredient. It might be the Cleano detergent. It's the one thing we're changing between the two groups and see if that works. The dependent variable is what are we seeing if it changes? Are the raisins going to dance more? Will people report having better breath? Are the pants going to seem cleaner? Will the bubbles be larger? What we're going to measure is our dependent variable. Everything else has to be the same. So if we start off with the flower pot experiment, or the flowers, and the talking to one group of plants. If I'm doing that experiment, talking to the group of plants is my independent variable. Everything else has to be constant. Same amount of sunlight, same amount of water, same type of pot, same type of soil. All those things have to be the same so they don't affect my experiment. The control group is my standard of comparison, is that group that has all of my constants, but it's my compare group. So it'd be the group that, like in the Dancing Raisin, it's the plain soda group. In the Cleano one, it's the one with plain water. It's the group that we're comparing it to. And our conclusion is, what do we learn from it? I learned that the Dancing Raisins dance more with baking soda and vinegar. I learned that the secret breath mint does work. The Cleano detergent doesn't work. Those are the conclusion is, what did you learn from the experiment? Remember, critical thinking is taking a new material and comparing it to what you already know to see if you agree with it. You do this all the time. You go to a store and there's a new Brussels sprout juice, the new soda, Brussels sprout soda. So you're going to say, well, why would I like that? I don't like Brussels sprouts. So why would I like a Brussels sprout soda? You're taking the information you already know. I don't like Brussels sprouts. Comparing it with this, oh, this tastes like Brussels sprouts. And you're comparing it. Would I like this? No, because it tastes like Brussels sprouts. Give them a shot. They're not bad after a while. And although science can help us answer a lot of questions, it cannot answer questions about opinions, feelings, personal beliefs. The Star Wars versus Star Trek debate will never be solved. I like them both. There's room in your world for both. Now, there will also be a scenario that you'll have to solve in the test, kind of like the pet controls and variable sheet. We'll go through this quickly. So Patrick notices that his rock is covered with a strange green slime. His friend SpongeBob tells him that clam juice will get rid of the green slime. Patrick decides to test this by spraying half the rock with clam juice. He sprays the other half with water. After 3 days of treatment, there is no change in the appearance of green slime on either side. So what is the one thing he's going to change? What is the one thing he's going to change is the clam juice. He's going to spray the clam juice on one side. Yes, that is a real thing. Then, what is the control group? If the group that has the clam juice is what he's testing, he has to compare it to something. His control group is going to be the group that does not have the clam juice. How will he know this work? What's he going to be measuring? Okay, well, he wants to get rid of the green slime, so what he's going to be measuring is the presence of whether or not the green slime disappears. And then after 3 days, he sees that the green slime of the clam side, he sprays the other side with plain water 3 days. I don't know how you spray water underwater. That's not my problem right now. But what he notices is there's no change. So what's his conclusion? What did he learn from it? The clam juice does not work. All right, so this is the notes on the presentation. If you have any questions about this, please feel free to ask. But otherwise, I've gone through this in class. I'm just giving this as an opportunity for those who may have missed it in class or want to review it again or just love hearing my voice. As soon as I can get this thing, I will stop recording. Thank you.